Okay, so since we're talking about the metric system, let's look at where the metric comes from. It comes from meters, which is our unit of measurement in the metric system, or SI units, however you want to look at that. But also just for things to be easier, I'll just say metric. So in the metric system, how we measure distance, our linear distance, so going from point A to point B, is going to be measured in meters. Now, as we've seen before with the metric system, all of our units, we can put prefixes in front of anything just to help us describe how many groups of 10 we have of something. So here's just a quick list, and you'll see this kind of happen a lot to kind of go along with how many meters are represented by each symbol. So 1 meter is represented with 1 meter. That's in the middle. That's like your ones place value. We move up, we get decameters. Deca sounds like decade, so 10. So it'll be 10 meters. 1 decameter is 10 meters. Move up again, we get one hectometer. A hectometer is 100 meters. We go up from there. The most common one, is 1 kilometer or 1 kilometer. A kilometer or a kilometer is 1,000 meters. Well, let's go the other direction though. Let's get to our decimals or our fractional parts. So if we go down, we get 1 decimeter. Deci against like from 10, but it's going the other direction, so it's a tenth. Bless you. So 1 decimeter is equal to 1/10 of a meter, or 0.1 meters. 1 centimeter is equal to 0.01 meters, or 1/100th of a meter. Centi, like century, 100, so 1/100th. 1 millimeter is 1,000th of a meter, or 0.001 meters. Okay, like like million is 1,000 thousands. Okay, so how do we do conversions with these? Well, it's going to be very important for you to remember these conversion factors. Not really. Just kind of have to remember the order because this is just place values, right? If you can remember that kilometer is 1,000, which most people can, meter is your ones place, and then milli would be your thousandths place. Everything else in the middle would be quite simple. Are you sure? Yes. Many people actually have come up with little acronyms and mnemonic devices so they can remember this. King Henry died a Monday drinking chocolate milk, which is one of the things that people have done. Um, you can do that literally all the time. And when we change the base unit here from meters to other things later on, you will see that these prefixes don't change. Like if I want to put Christopher's here, that's fine too. King Henry died by drinking chocolate milk. By for B meaning base, because I can put any base value I want here. The prefixes are only thing; they'll always be the same. The base changes. That's it. So anyway, let's look at how we can use this in a practical sense. So let's say I need to travel 3 kilometers. That's usually about an average 3, maybe 5 kilometers. 5K, that's a common run. Let's do 5K instead. So let's say I need to go 5 kilometers. I want to know how many meters is that? Well, 5 kilometers, kilometers literally means 1,000 meters. So this would have to translate to 5,000 meters. Right? That's quite simple. You're not using the dimensional analysis tool you taught us. Okay, let's do it that way. In fact, I tend to actually do any kind of conversions using dimensional analysis. So let's see what that will look like. So I would have 5 kilometers. I am going to go from kilometers to meters. So I know 1,000 meters is equal to 1 kilometer. That's not 1,000. Oh, sorry, that's 10 to the third. Why? Because we're talking about prefixes in the metric system, and they go up and down by values of 10, by powers of 10, just like the place values do. So to make things easier, a lot of times, what a lot of people will do is they'll write down 10 and then the exponent on it, which just tells us how far we've gone. So for instance, to get from kilometers down to meters, we have to go 1, 2, 3 steps. So this would be 10 to the third power. And you can always do that. If you go up, it will be a negative number. Okay? And we can look at an example of that next. So from here, I will get kilometers will go away, and then my answer will be 5 times 10 to the third meters. Oh, that looks kind of familiar. That looks like scientific notation, right? So scientific notation is actually a great tool that's used a lot whenever you're doing conversions, especially within the metric system. Because as you can see, it'll be very easily to leave things in scientific notation and to do those calculations. Because your answer will already, most of the time we're converting, have 10 raised to a power. Okay, let's go in another direction with this. So instead of going from kilometers to meters, let's say I have to go travel 36 meters, but I need to know how many kilometers this is. Okay, well, let's do a conversion. So if I go from 36 meters, I know that if I'm going to have 1 meter, I want to know how many kilometers that is. Going from 1 up, this will be 1, 2, 3. So that would be 10 to the negative third because I had to go up. Okay. If you didn't like that, you could have written this another way. You could have written this as 36 meters, and we still know that 10 to the third meters equals 1 kilometer. These will give you the exact same answer, because if you divide by 1,000, that's the same as having 1,000th already, right? Yeah. Dividing by 1,000 is the same as having 1,000th off the bat. Okay. So I wrote that fraction with its equivalent decimal just so you can see that they're the same. All right, so let's get back down to doing this problem. So in the end, we will end up with 36 times 10 to the negative third kilometers. Well, 36 times 10 to the negative third kilometers, that's not even in scientific notation. Nor is it anything that maybe some of you may say, I don't even recognize what that actually is. That's fine again. What you can do is we can, using scientific notation or using how we translate from scientific notation to regular notation, we can say 36, this is times 10 to the negative third. We know then that we need to move our decimal over 1, 2, 3 places to put our new decimal. Our place value will go here. So this would be 0.036 kilometers. Okay. And so that's it. Well, that makes sense. If I take 1,000th, multiply it times 36, I would get 0.036. Yeah, you would. So there are lots of different ways to do these because it's so simple. But because there's so many different ways, people tend to get confused. So that's why I personally stick to just doing dimensional analysis. I usually pick the positive powers because it makes it easier to see. It's up to you to decide what's going to be best for you. Some of you may leave, instead of doing this, you may leave it as a decimal and then just multiply across 36 times 0.001 and call it done. Doesn't matter to me how you do it as long as it's done in a correct fashion. And there are many different ways. And you'll see lots of other videos that will show you different ways as well. So the main thing to remember though is that each of these prefixes goes up and down by powers of 10. In fact, if I want to go from meters to kilometers or kilometers like I did before, a lot of times what people will do is they'll say, okay, go from here to here, let me move my decimal the same way. So because I'm going from meters and I'm going up to kilometers, or if you flip this down, be to the left, I go 1, 2, 3 to the left, 1, 2, 3 to the left, boom, there's my answer. So for a lot of people, that's what they tend to do, especially in my classes after I show them that. They're like, oh, that's so much easier. 1, 2, 3, I'm done. So that's it for measuring distance with the metric system. We're looking at linear measurements. It's called meters. Our prefixes are still the same. We still have kilo for 1,000, hecto for 100, deca for 10, deci for 1/10, centi for 100th, and milli for 1,000th. I'll see you soon.